We have layer 2s. We have app-specific chains. We have game-specific chains. We have tools like Substrate that make it really easy for you to launch a new chain. You can launch a new blockchain on Substrate in 5 minutes on a testnet. If you wanted to actually launch a parachain, it takes a bit longer. You have token economic considerations and everything like that. But the point of the matter is, the genie is not going back into the bottle. We're going to have lots of chains going forward. So is the experience going to be for a user? Are they going to be going from chain to chain to chain in MetaMask with 30 different pop-ups? Or is it going to be something where they can have a couple of home-based chains where they don't have to be constantly switching their network, but they have access to this expansive set of capabilities? Is it going to be one where the user might not particularly care the exact end blockchain on which this exact transaction is taking place? All they care about is having an enjoyable user experience. So that's something that we're thinking about as well. So as we have more and more chains, it's important to find ways for these chains to connect together and to work together. And part of that comes with XCM. Part of that comes with general message passing. And of course, remote execution, which I'll talk about. So if we think about where we're going, right, it kind of helps to think about where we've been. So in the current and the past, the model has kind of been to have a centralized deployment, meaning you pick a chain, you say to your users, here we are, come find us. And you might think hard about the chain that you're going to deploy to. You might try to pick the one that has the best trade-offs for whatever you're looking for. But at the end of the day, you are asking your users to potentially bridge in. If it's a new chain, you're asking them to potentially go and get a native token, perhaps that they don't have yet. But there are definitely some advantages. You have one deployment to maintain. You have one set of RPC nodes to run. You have one place to focus all your efforts. And that's awesome. But of course, that awesomeness kind of quickly becomes overshadowed by a demand and an interest in getting more users. And so you say, okay, we can't just stick to one chain. We have to have many different chains, right? And that's kind of where the multi-instance deployment arrives. And this would be less charitably, called a copy-paste deployment model. We're going to take the same exact contract and we're going to put it on a new chain. This is great. We have more users. Maybe some particular chains, maybe they have unique features here and there, and maybe we can take advantage of those unique features on each particular chain. And you might even see all of these chains accessible from the same website. But make no mistake, these chains, they don't know anything about each other. You can't access liquidity on another chain or have some sort of mutually beneficial relationship. It's totally segmented, chain to chain to chain. And so not only are you fragmenting your liquidity, but you're fragmenting your users, and you're providing an experience that might be better than a centralized deployment, but it's not a flawless or enjoyable experience. And I forgot to mention, now you're going to have to maintain deployments on 2, 3, 4, 10 different chains. And that's a Herculean task for any development team. And so Polkadot has kind of taken a different approach. And I'm sure you all know, but if somebody's new to Polkadot, I want to make sure to introduce Polkadot. Polkadot kind of took the idea starting in 2016 when it was controversial to say that the future was multi-chain. In 2016, if you said that the future is multi-chain, people were like, what are you talking about? Like, this doesn't make sense. Now it's a very common and accepted belief. So Polkadot said, let's let these blockchains specialize in what they do best. Since we know the future is going to be multi-chain, let's do everything in our power to allow the chains to focus on what they do best. So Polkadot provides shared security. They provide infrastructure and base layer components to make it pretty straightforward to launch a new chain. But they're not just saying, okay, go ahead, right, launch your chain, have your little island, and be happy there. No. We want to make sure that all the chains that are launching on Polkadot are interoperable with one another. They can talk to one another. They can benefit from the presence of each other. And so, of course, the idea is to create an ecosystem that's greater than just the sum of the parts. And this is enabled in part via XCM. And part of the early use cases, or kind of the first use case of XCM, right? We open up a connection to another parachain. Well, now we can bring that asset into Moonbeam, or now you can bring assets outside of Moonbeam. So let's say with Polkadot, for example, as soon as XCM is up and running and everything, we can now bring xCDOT into Moonbeam, and you can now take xCDOT out of Moonbeam and take it back to the relay chain. That enables some very cool things like staking with Lido's liquid dot contracts. So I think I have a slide on Lido's liquid dot contracts here, which I'll get to in a second. But the key idea behind XCM and general message passing and everything like that is for you to be able to access features on other chains, right? So within Polkadot, that's enabled by XCM. And outside of Polkadot, that's enabled by general message passing providers, such as Axelar, such as Nomad, and Layer 0, and others. These are just to name a few. So Moonbeam is a hub to be able to connect to all of these different chains, not just within Polkadot, but outside Polkadot as well. And we want you to be able to access features regardless of the chain that they're located on. So if you have a swap that you need to do, or you have an NFT that's accessible only on Cosmos or only on Avalanche, we don't want you to be restricted. We want you to be able to access that and to take advantage of the features that are located on those specific chains. And you can do that all without leaving Moonbeam. And so the key innovation here is general message passing, right? And general message passing is a way for blockchains to communicate, just like humans communicate. But it's structured in a way, especially with XCM. It's structured in a way that is very clear, so that the receiving chain has no ambiguity. It knows exactly what it needs to do once it receives this message. And that's important in order to keep a trustless environment, and in order for chains to be able to fire off messages really, really quickly and not have to worry about delays or anything like that. So let's talk a little bit about remote execution. So as I mentioned, kind of the first major use case of XCM was let's transfer assets, right? And this is great because it allows things like being able to put to work your dot tokens. You can put them into DeFi. You can put them into lending and borrowing protocols like Moonwell. And that was a radical innovation because, from the early days of Polkadot, right? The two main things that you were usually doing with your dot tokens was you're either staking them or you're putting them in crowd loans. You hadn't been able to use them in DeFi. And so XCM opened the pathways for that to happen, because you could take your dot from the relay chain, you could transfer it to Moonbeam, and then you could have an unlimited number of things that you want to do with them. And so that was a major breakthrough. And the second thing was, okay, now we're not just transferring assets, but now we want to kind of give instructions to other chains. We want to send a message from Moonbeam to the relay chain, and we'd like the relay chain to take an action. One of the examples that I gave in a workshop a couple times earlier this year was I would walk through the process of, okay, let's say you have dot on the relay chain and you just want to transfer it from account to account, but you want to trigger this directly from Moonbeam. So we could do that via XCM. It doesn't sound very crazy, but it is crazy because we're on a completely separate chain. We're not on Polkadot, we're on Moonbeam, and we're sending instructions to Polkadot. Polkadot relay chain is taking an action, whether it's transferring funds or doing another basic activity. That is pretty radical. And it goes more than that because we had staking thanks to Lido's liquid dot product. So Lido would transfer your xCDOT from Moonbeam to the Polkadot relay chain, and then it would stake it. And it would do all of that trustlessly. There's no off-chain components. Nobody's trying to manually pick a validator. All this is happening in an on-chain manner via XCM. which is really cool. So that was the second major story of XCM. But the third one, and this is the breakthrough that I'm super excited to share with you today, is to allow remote calls into Moonbeam's EVM via XCM. This means you could be on another parachain. This means you could be on the relay chain, and you can trigger a smart contract call to take place within Moonbeam. This is really, really powerful. And as we're sort of realizing this, this vision of interoperability within Polkadot, remote contract calls from other chains, I mean, this is like the best of the best. This is what we need. So I think I showed this example of Lido, and this was kind of, I think we went over it, so I probably don't need to spend too much time on the slide. But the idea here is that you're in Moonbeam, you have your xCDOT, and you can stake it in a Lido smart contract, which will trustlessly move it up to the Polkadot relay chain, and it'll go ahead and stake it. And they have a very sophisticated manner of how they choose validators. They make sure that you don't get slashed. They make sure that, welcome. Come on in. If you're just joining us, we haven't gotten to the workshop part, so there's still lots to go. I've just been given an introduction to Moonbeam and a bit of a background on XCM. So yeah, if you do have a laptop, go ahead and get that out, get it connected to the Wi-Fi, and then we'll jump into the demo portions. Oh, thank you. And I want to give a little context about the demo that I'm going to be giving. So one of the things that we're super excited about is being able to make trigger swaps, right? If you want to trigger swap on Uniswap, for example, or a Stell swap or Beam swap, you can do all of that from another parachain or from the relay chain. So I did prepare an example of this. But there's a lot of setup steps, and if we have multiple people trying to trade with the same asset, it's going to throw the pools kind of out of whack, and then it's going to, we're going to have like a strict deadline. And so I have a little bit simpler example to show today, where we just have a smart contract, and we're going to update the value that's stored in that contract. But I don't want you to think any lesser about this. I want you to think about you can do anything you want in Moonbeam's EVM remotely via XCM. Anything you want, with one exception right now, and that is creating a smart contract. Welcome. Thank you so much for joining. You didn't miss anything. We just had, I was just giving a quick introduction to Moonbeam, XCM, and Polkadot. And if you want to pull out your laptop and head to this GitHub repo, that would be awesome, and I'll jump right in. Yeah, so you cannot create a smart contract via XCM at this time because the create opcode is not supported. But it's not a problem. You just create the smart contract while you're on Moonbeam, as you would normally be. And then you can interact with that contract through XCM from another parachain or from the relay chain. Does anybody have any questions so far? Cool, cool. And the password for the Wi-Fi was WASM. It was the WASM network. I think WASM is the future, and then WASM. And I'm going to try to sit just kind of so I can see people if anybody raises their hand. And just stop me if something doesn't make sense or if you have any questions. Okay. We'll take a pause on the presentation for now. And how's this? Do you think the camera can still hear me? Hello, hello. If I put it down here. I can also hold it for a bit. It's okay. We could probably bring over one of the things. Okay, so I typically like to start demos with a completely fresh account so that we're all kind of starting from the same place. So I'm going to start in a similar fashion here. So Moonbeam uses Ethereum accounts. So if you don't have a MetaMask wallet set up, you'll want to go ahead and open that up. And if you don't have any connection to the Moonbase Alpha testnet, you'll want to go to docs.moonbeam.network and just click this button up at the top. And you'll see three options here. If you just press Moonbase Alpha testnet, I'm already connected, but it'll prompt you to add the network automatically to your MetaMask. Perfect. Yeah, no problem. Cool, so I'm already connected here. But like I said, I wanted to go ahead and create a new account. So we're all starting from the same place. So let's go ahead and do that. And what should we call it? Let's call it Summit SF. And did anybody have any trouble getting to the GitHub README? Cool, cool. If anybody has any trouble, let me know. So I'm going to head to the faucet page. And I'm just going to paste my address in here. All these links are in the GitHub here. And if you have any trouble accessing it or anything like that, just let me know. It's not meant to be kind of like a step-by-step per se, but it's meant to just like have all the links there for you to be able to access them easily. There is an exact step-by-step, which I'll share. I'll link to the doc site where you can go through a similar example on your own time, and you can see exactly what's going on. Okay, so we've got some funds. So let's make sure that we're connected here. Okay, and make sure you've added the Moonbase Alpha network to your MetaMask. So next step is we want to export the account, and we want to import this into Polkadot.js apps. Now we're going to import this into a specific link here. That is for Moonbase Relay Chain. So this is the relay chain of Moonbase Alpha. So if we go ahead and open this link up. Yeah. Oh yeah, the faucet, sure thing. It's just apps.moonbeam.network /moonbase-alpha /faucet. And it's also available here, this first link here. Yeah. Okay, so let's go ahead and open up Moonbase Relay Chain. Oh yeah, of course. Nothing yet. I just exported it. I just copied it. And we're just going to import it into here. So do you have this link here? It's the first link here under setup steps. Yeah, so that's taken you to Polkadot.js apps, but specifically for Moonbase Relay. And yeah, Moonbase Relay is the relay chain for Moonbase Alpha. We use it extensively for testing XCM integrations with other teams. So I want to make this as big as possible. Okay, so let's just add an account. And we're going to switch to, you could change it to raw seed here. And we're going to paste in the same private key that we exported from MetaMask. But you just have to add 0x at the beginning. Oops, hang on. Let me go ahead and export that from MetaMask. So go ahead and paste it here, but just put the 0x at the front. Did you add the 0x at the front? Yeah. Oh, change it to C. Oh, okay. So that actually, no problem. So go ahead and press save. It's important to press save because this will download a little file, and we're going to need this in the next step as well. So there's a decent amount of setup stuff, but we're going to get through all the setup, and this is going to be very fun once we have everything all in place. Does anybody not have the Polkadot.js extension installed? So it's very easy to install if you don't have it. You can install it just by going to Polkadot.js extension, and you can find it here. So I won't go through this step, but it's very easy to go ahead and grab it if you don't have it. The only reason that we need it for this step is we do a little validation in the dApp where we only allow you to withdraw, I think, to accounts that you own. So to prevent you from sending to an exchange or something like that, you do have to have the account loaded into the extension. So yeah, we have this Summit SF account here. And I want to actually import this into my Polkadot.js extension. So let's go ahead and do that. I'm going to press restore account from backup JSON file. And all we're going to do is go ahead and upload the file that just downloaded a minute or two ago. You're going to have to enter your password and press restore. And then you'll see it here under Summit SF. So cool. We can refresh this page. I really wish I could zoom in. Like, I can't zoom in anymore without making it unreadable. Okay. So we've got Summit SF. It now says extension because it's coming in from the Polkadot.js extension. So the next thing that we'd like to do is we'd like to, we got our faucet funds here, which is on MetaMask. And what we'd like to do is we'd like to make a quick swap. We'd like to get some XC unit tokens, which is the token of the Moonbase relay chain. So let's get a little bit of that, and then we're going to withdraw it, and then you'll see a balance here. In order to do that, there's a link here called Make a Swap. So this is a fork of Uniswap. It's just for the testnet, nothing fancy there. All we're going to do is make a quick swap on that. And I'll just make sure that I have the correct account set up. And let's say you want to swap half a dev. And you want to swap for XC units. You only need 1 or 2 XC units. You don't need a lot. So let's go ahead and press swap. And confirm the transaction in MetaMask. It'll take a minute or two to go through. Yep. Oh yeah, press select on Moon menu. You just have to select the default token list first. Does it come up now? Yeah. Awesome. Okay, so we're making the swap. The swap went through. I'll give everybody like a minute to just make the swap, because it might take a couple seconds to go through. So once you've made the swap, there should be another link here, which is now we want to withdraw this XC unit. We want to take it out to the relay chain. And so I have a link here. You can copy that link. And we'll go ahead and open up apps.moonbeam.network. There's a quick disclaimer. We'll get that out of the way. You can choose MetaMask, or if you're using another wallet, go ahead and choose that. You'll see a couple different assets here. Now, keep in mind, this is just for the testnet. So if you go to Moonbeam or Moonriver, you'll see a pretty longer list with real assets there. So we've got our XC unit tokens. Let's go ahead and withdraw. So all I did was press withdraw. And it's going to ask me to connect to the Polkadot.js extension. If you don't have it installed, you can just Google search Polkadot.js extension. And once I select that, it's going to ask which chain do you want to withdraw to. It's going to be AlphaNet Relay. You're going to have an address here, or a couple different addresses, perhaps just one. But we're withdrawing here to Summit SF. We'll go ahead and press max, and go ahead and press send. And confirm the transaction in MetaMask. This is going to take 20 or 30 seconds, and we'll see the funds then in Polkadot.js. If you want to check on the status, you can click here. And once it goes through, we will see our funds here in the Polkadot.js apps. And we can see here. So we have our balance of 2.7189. Okay.
So we did a cross-chain swap?
Yeah. It's more of like a transfer. I wouldn't call it a swap because you're just withdrawing. You perform a swap on Moonbeam Alpha, and then we're just withdrawing funds out to the Lido chain. So just a cross-chain transfer is all.
Within the wallet. So like earlier it was in MetaMask with Ethereum address.
Yeah, exactly.
Then it was in Polkadot.
Yeah, exactly. Yeah, exactly. So you have it in the Polkadot.js extension now?
Good. Yeah.
Okay, awesome. Perfect. So once you have that, there's a couple more setup steps that we'll do, and then we can get into the fun part.
And can you explain why can't we just directly use it in Polkadot.js and get the fund?
Yeah, of course. I could just send you all funds like that I already have. It would just be like sending Polkadot tokens, right? Like you'd probably already have Polkadot tokens, so you don't need to go get some. But because this is like a testnet, we have to kind of go through that extra step. And we don't have a testnet dispenser for XCM. We only have the dispenser for dev tokens. That's why we had to make the swap. That's all. And we're going to do a little bit of an address conversion thing here. So if you go ahead and copy the account here that you have. So for Summit SF, I'm just going to copy this account. And we're going to convert this to hex. And Sean Tabrizi, Parity developer, has this very useful converter. So I recommend opening that up. And it's going to look something like this.
Why do you need to convert hex?
Because it's in a Polkadot format right now. And we want to get the long 0x one. And then we're going to take that, and we're going to convert that into a derivative account. So now's a good time to talk about derivative accounts. Why do we need a derivative account for this remote execution? Remote execution via XCM is it's dispatched by the sovereign account, and the sovereign account is a very highly privileged account. It can do a lot, and so in order to do this in a safe manner, we have to kind of isolate you to your own specific derivative account. And your derivative account is deterministic. It's easy to calculate, and it's just yours, right? So if I have the account that we just created, right? What was that called? Summit SF. We're going to create a derivative account from this, and the only way that you can access the derivative account is if you have this one. So another thing that's interesting about the derivative account has no private keys. Nobody knows them, not even you. So how do you access the funds in this account? Well, you can access the funds through XCM instructions. So you can't import the derivative account into MetaMask. You can't do anything with it other than send it XCM instructions. So if I were to send $5 to it via of USDC, I can't get it in MetaMask, but I can send an XCM instruction, say, hey, send me this USDC. And as long as it's coming from the right account, you'll be just fine.
Is it similar to account abstraction in Ethereum?
I don't believe that it is. But might be a conversation for.
Yeah.
Let me see. It might be. We'll talk about that. Okay, so we just copied this account here, right? Summit SF. So let's copy that into the account ID to hex. And okay, perfect. We get this big long hexadecimal account. So keep this up. I'm going to have you install something very small. And we should probably put this into like a hosted version so that you don't have to do this. But there's an XCM tools repo that was created by Alberto, who's the developer relations manager at Moonbeam. And let's just go ahead and clone this repo really quick. This is going to allow us to calculate our derivative account. Let me zoom in. And we're just going to clone this repo. And after we clone it, just go ahead and navigate into it. And then we're just going to run yarn. We'll make sure everything is all set here. And there is a command that I have in the repo, which is all set, except for it's missing your hexadecimal account. It might also be missing some backticks. So let's actually just put this together manually. So we're going to calculate multi-location derivative. And we need to provide a WebSocket. And so this one, you just provide the one that's specified here. So it'll be the W flag. Next, we're going to provide a --A flag, and we're going to provide the hexadecimal address that we have just calculated here. And lastly, the last step, and probably the most confusing one here, is we're providing the name of the network in hexadecimal. So why do we need to do it like this? Moonbase's relay chain is based off of West End, and so we're actually providing the name of West End here. But yeah, not to worry, just you can copy this. And we need this to, in order to calculate the correct derivative account for this type of network. That's why we're saying that it is a West End style of account.
What is West End?
Oh, it's okay. West End is a test net within Polkadot.
This is based on.
Correct. Yeah. So it's like a clone of the West End. Yeah. So we get here a derivative account. We're interested in the 20 byte one here, the Ethereum style one. So I want to look this up on the Explorer just because I think it's helpful to kind of like see it in real life, kind of see what's going on here. So there's nothing here, but this is our derivative account. And so if we want to do anything here, this is where any EVM transactions are going to take place on this account. So we do need to fund it. We need to send some dev funds to it so that it has fuel to do the transactions that we want. So let's do exactly that. Let's send it half a dev or so to this particular account. So we'll go ahead and send half a dev. And all right, we're almost on to the fun part. I think we are onto the fun part now. Now we've got a simple contract here that we're just going to deploy and then interact with. So you can see on this GitHub repo, it's just a simple storage contract. Yeah. Yeah, no problem. No, all good, all good. Yeah, so did you get the derived account here?
That's what I'm
Sure. Yeah, so just follow these steps right here, this TS node. You can copy and paste. You might have to add backticks here, or if you just keep it all in the same line, that works too. Let me zoom in a little more. So the three things that we're providing here are a dash dash W.
Yeah, I got that part after this.
Okay, you got, did you get the 20 byte address?
Actually, it was giving me some TS.
Oh, yeah.
It doesn't work in.
You ran yarn, right?
Yeah.
Oh. Okay, so once you have this, all we did was send funds to it. So we've got half a deck here. Yeah, so once you have this, now we're ready to go ahead and do stuff. So let's just open up Remix. And I have a simple contract that I'm going to compile and deploy. So we'll go to contracts. I have it here. If you don't have it, just copy and paste it from the README. So all this does is stores a value. It doesn't start with anything. It starts with 0. And we can update the value, as we'd like. So all I'm going to do is compile this. We're going to switch to injected provider MetaMask. And then we're going to deploy it. And we'll confirm it. I think it's I think it's something like a problem with installing. It's weird.
I did yarn.
I'll send you like the full instructions afterward,
Okay.
so you can get everything. Okay, so we deployed this, and let's just take a look at it. So we've got, if we retrieve, we see it's got a value of 0. So there's nothing there right now. But what we're going to do is, via XCM, we're going to update this. So we need a couple of things. We need to have the contract address here. We also need to have the call data of what we'd like to update it with. Maybe there's like an online playground or something, CS mode playground where you could run that command or something like that. It's not worth it.
Yeah, I think it might be not in yarn. There is a additional library.
Okay, cool. So let's say that my favorite number is 46. So I'm going to provide this, and then I have the call data here, which we will copy from this particular spot. So I'll give a moment for everybody to get to this point. And what we're going to do then is we're going to go ahead and set up this EVM transaction as an extrinsic. We're going to set it up. We're not going to submit anything yet, but we just want to get the encoded call data, which we are then going to provide to the XCM transaction that we're going to send. So you should see I don't know if I put a link for Moonbase Alpha Polkadot.js, but that's okay. It's very easy to get to. So let's just open up a new tab. And you're going to go here to Test Networks and scroll down to Moonbase Alpha. Any of these options is fine. Press Switch. Okay, and I've got a couple accounts here. You just need to have one account here. It doesn't matter what it is. But just because some options are hidden until you have an account listed here. So if you don't have one, just create a dummy account, and then we'll move right along. So we'll go to extrinsics, and then we're going to go to an extrinsic or a palette called Ethereum XCM. It's very appropriately named. And there are only four or five options here. We're interested in transact. Again, we're just structuring the transaction. We're not actually submitting anything here. So we're going to choose V2 because we always want the latest version in this case. And we need to provide a gas limit. So I think the gas limit was something like 50,000, but we're going to provide a safe overestimate. We'll say 75,000. The type of action we're going to make is a contract call. So that's what we've got selected here. And then we need to provide the contract address. So just head back to Remix, copy the address of the storage contract that you deployed, and paste that in here under call. Next, you have a value. And for value, we're going to leave this blank. If you're making a swap and you're providing tokens, then you're going to have to put native tokens. You're going to have to put a value in here. But we're not doing that here, so our value is 0. We do need to provide some contract call data. So that's what I'm going to copy here. And let's just paste that into the input section. So that's it. We're not going to submit this. We're just going to copy the encoded call data that's here. So don't copy the encoded call hash. We want this longer one here up top, which is encoded call data. So think of this as we're preparing this EVM transaction, and we prepared it here in Moonbase Alpha, and then we're going to send it from the relay chain via XCM. So there's a bit more setup that we need to do, but this is our EVM transaction right here. That's kind of the extent of it. So let's go back to Moonbase Polkadot.js apps. So remember, this is the relay chain. We're going to head over to, same thing, developer, extrinsics, and just make sure you have the right account selected. The Summit SF one was the one that I created. And then we're going to go here to XCM palette. And this is where it gets a little bit tricky. So pay attention to the exact steps and make sure that you have them exactly. And if we get it wrong, we'll try again and we'll fix it. So there are a couple options here. We're interested in sending. We're going to send a message from the relay chain to Moonbase Alpha Parachain. So choose send. We're going to choose V1. We want the latest. We're choosing the destination of our message. So remember that in XCM, you're always defining a destination based on where you already are. So we're at the relay chain, so we don't need to go like up or whatever. We don't need to go to another level. We just have to look to the relay chain and say, like, how do we get to it? And the way Moonbase Alpha is, we have to look from the relay chain to the parachain. The way we can identify Moonbase Alpha is via one option, and that is so x1. So parents of 0, we're staying at the same level, the relay chain that we were at. And we identify Moonbase Alpha by saying parachain ID of 1000. This is just something to remember. There's nothing particularly special about it. It's just its ID. So that's that. That's going to send the message. Now we have to construct the actual message. And so we're going to specify a message type of XCM v2, again, the latest version. And now we're going to construct our actual XCM message. So we're going to press add item to give an instruction. We're going to have 3 distinct instructions here. So you can press add item 3 times, but this is going to be the top add item, not the bottom one. So just add a total of 3. And the first one is called withdraw asset. That is correct. We're going to keep that as withdraw asset. But under it, we need to actually specify the asset that we're going to withdraw. So underneath withdraw asset, go ahead and press add item. And the first thing you see here is a concrete option. We can keep that. You have a parents option. We're going to do a couple things here. So we're going to go ahead and we need to pay for this transaction. So we're going to specify a amount of assets that we need to pay. And we also need to identify the asset that we're paying with. We're paying with the dev token, and that can be identified by x1, pallet instance of 3. So let's go through the options really quick. We have parents of 0, interior x1, palette instance 3.
What is the balance?
Yeah, good question. So that corresponds to the balances palette, which is the native token of the chain that we're on. So we're saying take the native token, take the dev token, and we're going to use that to pay for the XCM execution. Oh yeah, sure. So on Moonbeam, the 3 palette corresponds to balances, and you can find this in the librs file. If you look here for 3, oh, there's a lot of 3. Let me look for balances. Let me see. I think it's right around here. Here we go. So if you look here, balances of 3. Oh, so this is for the Moonbeam, but if we go to the Moonbase one, that might be slightly different. So for Moonbase Alpha, yeah, now we can see palette instance 3. That corresponds to the balances palette. Yeah. Okay, so back to here. So we're saying this is a fungible asset, and we want to take an amount here that's going to be 17 zeros. So (17 zeros, 18 digits in total. And that's going to correspond to 0.1 dev. It's an overestimate. It's a very high overestimate. So I just pressed add item again because underneath withdraw asset, but we finished the first set of instructions. So our second one, we're putting money aside for the fee, but now we actually have to pay the fee. So the second one is going to be by execution. XCM is very modular, and so we're very pedantic. We're saying, okay, put aside money for the fee, now pay the fee. With by execution, we're specifying the exact same parameters as before. Concrete, 0, x1, palette instance 3, fungible, and we're providing this same number here, the 1,000. Sometimes it doesn't like copy and paste within here. Yeah, so I got to type it out. Okay, that's fine. All this is the same. Weight limit is unlimited. And now we're done with our second instruction. So our third instruction is transact. And this is where the actual message gets executed. So we're going to choose sovereign account. Sovereign account is very privileged. And for require weight at most, we're going to choose 4 billion. So you can put 9 zeros here. And that's almost it. All we need to do now is put in the call, which we got here. So copy your encoded call data. And go ahead and paste it in here. And there's one thing that I'll do. I'm just going to open up the Explorer so that I can be ready to look at this transaction and see what's going on. In the Explorer, you can see the exact events that are coming up. So take a quick glance, make sure everything looks good. We're withdrawing, we're buying execution, palette instance 3, and yeah, everything looks good. If this is successful, then it will update the contract from 0 to 46 in the case of my contract. So go ahead and enter your password and submit it. Okay, and it went through. Let's take a look. Let's see. Things are looking good. It says succeed stopped. And we do need to give it like a block or two for this to be updated. And we can see that the value is updated from 0 to 46. We can do the exact same thing with a more complex contract. It's just that you can see there was a decent amount of like setup steps that we had to get in order to get the faucet tokens, in order to get the XC unit tokens, in order to move funds around to the right place. But just to kind of like go over, right? What were the steps that we set up here, right? This was not actually that complicated here. We're setting a gas limit. We're saying we're doing a contract call. We are providing the address of the contract that we want to interact with, choosing the value. We're choosing the contract call data, which anybody can create in Remix. You might prefer to just get the contract call data in MetaMask. You don't need to use Remix. You can, enter the exact, you can change the number to whatever you want, get the call data, and then that's what we have here. Then we get the encoded call data. We go back to the Moonbase relay chain. And I'll admit, this does look a little bit complicated and a little bit intimidating. But once you've done this like once or twice, it's pretty intuitive. And it's pretty straightforward. So
the first step was setting up the instruction. Like when we had call data on Moonbeam, we are setting up like, okay, this is the instruction we want to modify on.
Exactly. Yeah. So all we are doing here, and you can do this programmatically via the Polkadot API. All we are doing here is providing all that data, including the input call data. And then it's giving us the encoded call data. So this is packaging it up nice and cleanly for Polkadot to be able to work with.
So we have various functions on smart contract every time I create an instruction here. Like isn't it like a lot of steps? Like if I just want to change another 46 to 48,
no, so you would do it via the API. So you would let's say you had a different value, right? Like you had 12 or whatever. You would calculate the call data in your application, and then you would make a request to the Polkadot API saying, okay, here are all the parameters that I want. Here's the input data, which you would calculate locally on your app. And then Polkadot API would say like, okay, here's the encoded call data.
Got it. So I'll get one post processing step in my front end.
And then you would submit it here. And this step, the most complicated part about this step really is probably getting the weight correct. And you can calculate this deterministically. There's a gas to weight ratio that you can use. And keep in mind that the example we have on the doc site. So I have a minute or two left, so I'll wrap it up. If you go to the doc site, we have let me just go directly to the link. So it's remote EVM calls through XCM. We have here a full example, which I will update the repo and add this to the repo so that you can see it, or you can just go to the doc site. But anyway, we have a very similar example here, and we only provide 4 billion weight, which is not enough if you want to do something more complicated like a swap. So make it 40 billion, and then you'll be fine. And then also keep in mind that your gas limit would change too if you're doing a swap. So you're going to need 150,000, 180,000 gas. Then you'll get a new encoded call data. You'll get a new all of that.
So the derivative the only way you can send transactions to it is Polkadot API dashboard, or
it's through XCM.
XCM.
Yeah.
So if that derivative prompt is only for XCM, you can't send
Correct.
transactions otherwise.
Correct. Yeah. You got it perfectly right.
Why would you make use the same rates?
So it wasn't like a proxy account. We didn't set up a proxy, but it's that's a good question. It's more of a So it's tied to it in the sense that yeah, I believe you have to use the same. Well, if it depends. So we could use a different Polkadot.js account. You didn't need to use that particular one. However, we need to use we need to fund the right derivative account, if that makes sense. So we could use I think we could use a different Polkadot.js account, but it would have to be interacting with that same derivative account. It's derived from the ETH one, yeah. Yeah.
Do you have instructions for sending transactions to the XCM, like the followers or inputs?
Yeah, exactly. That's right here.
Remote call. Oh, it's right there.
Yeah. Mm-hmm.
So can you not do these instructions
Sure. Sure. So right now it's only on Moonbase Alpha, so it's not yet in production. You can't create a new contract. And then you have to be within a specific gas limit. And keep in mind that there's a weight limit. And you have to keep enough weight to do your normal XCM stuff. So let's say you have 4 billion, right? And then let's say 4 billion is just for your EVM call. That's not going to leave any weight for the normal XCM processing, and so you might need to leave a 25% buffer or something. But in terms of what can you and what can you not do, you can do anything that you can do with normal EVM, as long as you're abiding by this exact weight and gas limit. Oh, just because we don't support the create opcode yet via XCM. And that doesn't mean that we won't support it at some point. It's just not supported yet.
Let's say there's the example sign.
Yeah, for sure. Sure.
For example, the XCM column, then this one's the XCM column is a very general purpose way of doing a very specific thing. The example sign does. So the example sign is very specific.
So we did transact through derivative. Yeah. Oh yeah. So the index one, I showed that one actually in a different demo, I guess. But yeah, we can do transact through that index. We can do that as well through the numbered one. That was typically for. I think we're actually phasing that out though, and I think we're going to go with the transact through sign going forward, as opposed to that index one.
So there's this idea of derivative account. Do you think it's going to be the universal only, or do you think Astar when others are using the same?
I like to think that with all working open source and stuff, that people will, other teams will perhaps adopt it as well. But I don't know for sure. Yeah. Let me. I'll post the link, and you guys have been. You all have been very attentive, and thank you so much.
Where are you posting it?
Oh yeah, on this bit.ly. So do you have this original link? Yeah, just take a picture of this. This is the link to just a README repo, which has kind of the details of the workshop. And I'll post the docs link there. Yeah, thank you so much. Thanks everyone.